Welcome to Cambridge IGCSE Physics, Lesson 53.1, Background Radiation. Today we explore the radiation that surrounds us constantly in our environment. This is core content for your examination, focusing on understanding what background radiation means, recognizing that it's always present, and identifying its various sources. Let's begin this important physics lesson. Let's examine our learning objectives for today. By the end of this lesson, you will be able to, first, know what is meant by background radiation. This means understanding the definition and characteristics. Second, understand it's always present in our environment, recognizing that background radiation exists everywhere around us continuously. Third, recognize natural and artificial sources, identifying where background radiation comes from. These objectives align with Assessment Objective 1, which tests your knowledge and understanding of physics concepts. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, background radiation, which means low-level ionizing radiation that is present everywhere in our environment. This radiation exists at all times and in all places. Second, natural radioactivity, which means radiation that comes from naturally occurring radioactive sources like cosmic rays and rocks. Third, ever-present, which means continuously existing in all environments without interruption. Understanding these terms precisely is crucial for your examination success. Let's explore what background radiation means. The fundamental principle states that background radiation is low-level ionizing radiation present everywhere in our environment. This means that no matter where you go on Earth, there will always be some radiation present. The definition is radiation that exists naturally in the environment at all times and locations. Key characteristics include it cannot be eliminated completely. Even in the most shielded environments, some background radiation remains. It varies slightly by location. Mountainous areas typically have higher levels than coastal regions. It's measured in counts per minute using a Geiger counter. The diagram shows a typical Geiger counter reading of 15 to 20 counts per minute, which represents normal background radiation levels. Background radiation comes from various sources. Natural sources provide the majority of background radiation. First, cosmic rays. These are high-energy particles from outer space that constantly bombard Earth's atmosphere. Second, rocks and soil contain naturally radioactive elements like uranium, which decay and produce radon gas. Third, food and drink contain radioactive isotopes like carbon-14 and potassium-40 that we consume daily. Fourth, air contains radon gas that seeps from the ground. Artificial sources contribute only a small percentage and include nuclear weapons testing from past decades, medical procedures using radioactive materials, and nuclear accidents. The pie chart shows the relative contributions of each source to total background radiation levels. Now we examine how to measure background radiation. This follows Cambridge IGCSE practical requirements. The standard method uses a Geiger-Müller tube connected to a counter. The procedure consists of these steps. First, switch on the Geiger counter and allow warm-up time, typically 2 to 3 minutes for stable readings. Second, record the number of counts for several minutes without any radioactive source present. Third, calculate the average count rate per minute by dividing total counts by time. Fourth, repeat measurements several times for reliability and calculate a mean value. Typical background radiation values range from 15 to 25 counts per minute. Safety considerations are minimal because background radiation levels are very low and pose no immediate health risk during measurement. Let's work through our first example. The problem states, a Geiger counter records 180 counts in 10 minutes. Calculate the background count rate. We are given total counts equals 180 and time equals 10 minutes. We need to find the count rate in counts per minute. Step 1, write the equation. Count rate equals total counts divided by time. Step 2, substitute the values. Count rate equals 180 divided by 10. Step 3, calculate. 180 divided by 10 equals 18. Step 4, state the answer. The background count rate is 18 counts per minute. This result is within the normal range for background radiation, confirming our calculation is reasonable. Example 2 shows how to analyze radiation measurements. The problem compares readings with and without a radioactive source. The data shows background radiation at 20 counts per minute and total reading with source at 120 counts per minute. Now we analyze systematically. First, identify the background level. This is 20 counts per minute, which must always be present. Second, calculate the source contribution by subtracting background from total. 120 minus 20 equals 100 counts per minute from the source alone. Third, find the percentage increase. 100 divided by 20 multiplied by 100 equals 500% increase. Fourth, interpret significance. The source produces 5 times more radiation than background, showing it's significantly radioactive. The graph clearly shows this dramatic difference between background and total readings. Understanding background correction is crucial for accurate measurements. Background correction is necessary because all radiation measurements include background radiation, which exists everywhere. The correction method involves 3 steps. First, measure the background count rate with no radioactive source present. This gives the environmental radiation level. Second, measure the total count rate with your radioactive source in position. Third, subtract the background count rate from the total count rate to find the true source activity. The formula is source count rate equals total count rate minus background count rate. For example, if the total reading is 85 counts per minute and background is 18 counts per minute, then the source count rate equals 85 minus 18, which equals 67 counts per minute. This represents the actual radiation from your source alone. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks you to list 3 natural sources of background radiation. Think about the sources we discussed earlier. Question 2 is intermediate level. It states, a detector shows 240 counts in 8 minutes. Calculate the count rate. This requires you to apply the count rate formula we learned. Question 3 is advanced level. The question gives, total reading equals 95 counts per minute, background equals 22 counts per minute. Find the source activity. This tests your understanding of background correction. For all questions, remember to show you're working clearly, include units in every step, and check your answers make physical sense. Write your answers now before looking at the solutions. Background radiation knowledge has many practical applications. In nuclear medicine, doctors must correct for background radiation when using radioactive tracers for medical imaging. This ensures accurate diagnosis by measuring only the radiation from the medical source. In environmental monitoring, scientists measure background radiation levels to detect pollution from nuclear accidents or waste. Any increase above normal background indicates contamination. In space research, understanding cosmic ray background radiation helps design spacecraft shielding and protects astronauts from harmful radiation. Career opportunities include medical physics, where professionals ensure safe use of radiation in hospitals, environmental science for monitoring radiation safety, and nuclear engineering for power plant operations. Specific roles include radiographers who operate medical imaging equipment, health physicists who measure radiation exposure, and nuclear safety inspectors who ensure regulatory compliance. Let's review the solutions and summarize key concepts. For question 1, 3 natural sources are cosmic rays from space, rocks and soil containing uranium and producing radon gas, and food and drink containing carbon-14 and potassium-40. For question 2, count rate equals 240 divided by 8, which equals 30 counts per minute. For question 3, source activity equals 95 minus 22, which equals 73 counts per minute. The key points to remember are, first, background radiation exists everywhere continuously. You cannot escape it completely. Second, natural sources provide the majority of background radiation, with cosmic rays and radon being major contributors. Third, always correct measurements by subtracting background count rate from total readings. Fourth, typical background levels range from 15 to 25 counts per minute. Understanding background radiation is fundamental for all nuclear physics work and ensures accurate scientific measurements.